Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 12 Linear Programming in Exercise 12.1, sixth sum. So what we need to do is the given linear programming problem, we need to solve it graphically. Okay, to draw the graph, we need to use the given information. So what we have here, minimize Z. So what is the given Z here? X plus 2y is given, and subject to constraints, we can see the four inequalities over here. So these are the subject to constraints that we have. So first I'll tell you the process. What we have to do is, so here using the four inequalities, no, okay, we need to identify the common solution space. Okay, common solution space we have to identify. Okay, that is we technically we call it as a feasible region. Okay, this term we will use here. Okay, so we need to identify whether feasible region we have for the or four inequalities. I mean, common solution space is available or not. We are going to check if it is exist. Okay, that is one thing. If it is not existing, okay, if it is not exist, then no solution, no solution for the given Z. In case if it is exist, again we have to check whether it is bounded or unbounded. Okay, if it is bounded, how we can figure it out? This common solution space, you will get it like a polygon. Okay, so it will be like a closed figure. So closed figure, then it is bounded. So feasible region, a solution exists, that is feasible region. If it is available, then it can be like either it will be in the bounded or unbounded. If it is bounded, what we have to do is it will be looks like some polygon I have told, right? So that corner points wherever the two lines meets, no, in the polygon, so that is the corner point. That corner point one by one we have to substitute in the given Z. Then whatever the results you will get, so out of those you have to find out the least one, that will be the final result, minimum value of the Z. Okay, if it is unbounded, again the same. What we have to do is you have to take the corner points of those and you have to substitute in the given Z. Whatever result we will get, that minimum value, it's not like 100% is the minimum, it may or may not. So if it is a bounded 100%, that will be the minimum value. Okay, I'm substituting the corner points. Whichever corner point is giving you the least one, that is the minimum value of the Z. But in case of unbounded, whatever value you will get it using the corner points, if you substitute in the given Z, the minimum value whatever you choose, so that will be may or may not be the minimum. To confirm it, what we have to do is, with the help of the minimum value, you have to frame a new inequality with the help of the Z. Okay, then you have to find out the solution space even for that equation. Suppose let's take we are getting the minimum value as a some a. Okay, so with the help of the given set, what you have to do is x plus 2y minimum, right? So less than symbol you have to use. If it is a maximize, then greater than symbol, so a. Now you have to identify the solution space in the same graph. Okay, now feasible region, and whatever graph we draw for this, whether it has a common solution or not, we have to identify. In case if there is no common solution space, common solution between x plus 2y less than a and for the feasible region, then whatever value you will get, that is the minimum. We can 100% we can confirm. So common solution space should not be there for the feasible region. Okay, between feasible region and for the new inequality whichever we are framing, for that common solution space should not exist. If it is not exist, then it's a green signal. Okay, so whatever value you'll get, we can confirm it as a minimum. Okay, so this is the process. Now let's start doing with the sum. Okay, what is the first thing that we are going to do? We are going to identify the common solution space for the all the four inequalities. So to identify, what we have to do is, first we need to convert the given inequalities as equations. So let to draw the equation, no, in the graph, minimum 2 points are required for us. So 2x plus y equal to 3. So to draw the inequality, how many points are required? Minimum 2. Maximum is up to you. So if x equal to 0, the corresponding y value, let's find out. 2 times of 0 is 0, y equal to 3, then y equal to 3 here. Okay. Now same way, if y takes the 0, no. If y takes the 0, then what will be the x value? 2x plus 0 equal to 3, 2x equal to 3, x equal to 3 by 2. So that is, we can say 1.5. So 3 by 2, it's a 1.5. Okay. So now let's draw the graph and plot these points. And on joining the points, we can able to get the line of 2x plus y equal to 3. Okay. And one more thing, you can see the last two inequalities. No, x greater than x comma y greater than or equal to 0. It means that basically in a graph we will have a four quadrants. Okay. So out of four quadrants, what we have to do is all the four inequalities, common solution space we have to identify. Basically, we need to filter, right? So if you notice this particular two inequalities, no, it shares the common solution only in the first quadrant. Okay. So then later for the given two inequalities also in the first quadrant, what is the common solution space only we are going to identify. So I'm going to give more space for the first quadrant because we know that all linear programming problems we will have only in the first quadrant. So I'll give more space for the first quadrant here. Okay, if you are drawing an actual graph, no issues, but when we are drawing here, no, we have to give the equal spacing. So generally we need to do it in the graph. We'll get the accurate figures. Okay, I hope these are enough. Same way here. Okay, now let's plot the points. What's the first point that we got? 0 comma 3. Okay, if x is 0, it will be in the y-axis, right? So 0 comma 3. Where do we have that point? So this particular coordinate point is the 0 comma 3. And next one, 1.5 comma 0. 1.5 between 1 and 2, right? So this point will be 1.5 comma 0. Now let's join both the lines. Okay, if we join, yeah, we are getting the line of 2x plus y equal to 3. Okay, so this is the line of 2x plus y equal to 3 line. Okay, now after drawing this 2x plus y equal to 3 line, you can see the graph is dividing into two portions. So this side one portion, okay, this side one thing, and other one is this side. So we need to identify where we have the solution for the given inequality, whether right side of this line or left side of this line. Okay, so for that what we can do is randomly take any point which lies in this portion, any coordinate point. One coordinate point is more than enough for the testing, and same way here also. Okay, so let me take 0 comma 0 no first. Okay, so I'm going to take randomly one point which lies this side, that is 0 comma 0, and I'm going to substitute in the first inequality. So if in place of x and y, if I replace 0 comma 0, no, 2 times of 0, 0, what is the result? 0, right? Is it 0? What is the given here? Greater than or equal to 3. Is it true? Which is false. So that means we don't have solution to for the given inequality for this side. Left side we don't have. Okay, then obviously the other side only will have, but anyway that too we can confirm. So let's take any point. Shall we take 2 comma 1? So let's take 2 comma 1 and substitute in the inequality, and let's see whether it satisfies or not. Since it's not satisfied left side, then obviously right side only you will have. So 2 comma 1 I am going to take now. So 2 times of 1 plus, sorry, 2 times of 2 plus 1. So what is the outcome? 2 2s are 4, 4 plus 1, 5. So 5 is greater than or equal to 3. Is it true? Yes. Is it true? So then what we can consider in this, the for the given inequality, we have a solution space this side. We have a solution this side to the graph. Okay, enough. Now, same way for the second inequality also, we have to identify the solution space in the same graph. Okay, so to find the solution space, first we need to draw the line of x plus 2y equal to 6. So I'm converting the given inequality as a equation. To draw the graph, minimum 2 points are enough. If x equal to 0, then 2y equal to 6. 2 ones are 2 3 times. Then y takes the value 3. If y equal to 0, no, then x will be like x plus 2 times of 0 equal to 6. Then x equal to 6 we are getting. Now these 2 points, let's plot it in the same graph. 0 comma 3. So 0 comma 3, same here we will have same point. 0 comma 3. Then 6 comma 0. 6 comma 0, where do we have here? 6 comma, this point is 6 comma 0. Now let's join both the points. Now after drawing this yellow line, no. What is this yellow line? This is the line of x plus 2y equal to 6. Forget the previous, the red shaded portion. Now after drawing this line x plus 2y equal to 6, this yellow line, you can see the graph is dividing into two portions. One is above, the other one is below. So we need to identify the solution space for the given inequality. So randomly take any value. So I'm going to take 6 comma 1. Okay, 6 comma 1, and let's see whether inequality satisfies or not. So x plus 2y, that is 6. If I replace x as a 6 and y as a 1, what is the outcome? 8. Is it 8 is greater than or equal to 6? Is it true? Yes. Condition is satisfying. So not only 6 comma 1, any point you take from this side, it will satisfy. So what we can consider from this, the solution space we have for the second inequality is above. Okay. So we have here. Now you can notice wherever the yellow line and red line is overlapping, that is the common solution space, the double shaded one. But don't misunderstand, it is also there in the second quadrant as well as in the fourth quadrant. So the solution wherever the yellow line, red line meeting in the first quadrant only the feasible region. Okay, I'll explain that also now how it is. So now what is an other two inequalities? X comma y greater than or equal to 0. That is, if x is greater than 0, no. Where is the solution for this? Let's consider x equal to 0. X equal to 0 line is what? Y axis is the x equal to 0 line. Okay, so this is the x equal to 0 line. Now the graph is dividing this y axis into two portions, the right side and left side. So where do we have a solution? We have to identify. So what is the given inequality? X greater than or equal to 0. If x is greater than or equal to 0, we have a solution in the right side. Okay, right side. That means first quadrant and fourth quadrant is the solution for the x greater than or equal to 0. So remember, what is the solution for this? First quadrant and fourth quadrant, okay, is the solution space. Now if y greater than or equal to 0, that is y equal to 0, y equal to 0 line is what? This x-axis is a y equal to 0 line. Okay, but what is the given inequality? Y greater than or equal to 0, right? Here this x-axis dividing the graph into above and below, so two portions. So where do we have a solution for this? Oh sorry, y equal to 0 line this side, no, above and below. So the given inequality is y greater than or equal to 0. That means above the x-axis only y is greater than or equal to 0, right? That means first quadrant and second quadrant is the solution for this. First quadrant and second quadrant. Now you can notice what is the common solution space for both x comma y greater than or equal to 0 means only in the first quadrant. Okay, now first quadrant only is a solution. Now you can notice that wherever that yellow line and red lines are overlapping in the first quadrant is the common solution, that is the feasible region. So basically this is going to be the only in the first quadrant. It's fully, after that, little it's enough to for shading. So we can say that the double shaded portion in the first quadrant is the feasible region for the given inequalities. Okay, enough shading. So now you can see, is that the common feasible region, is it a bounded? It is not a bounded, right? It is not a bounded because it's an open figure. So what we need to do is, if it is unbounded, normally what we will do, we'll take the corner points as usual. So what are the corner points that you can see? All the four lines that we have drawn, no, that is 2x plus y equal to 3, x plus 2y equal to 6, then x equal to 0, y equal to 0. So in the bounded, in this feasible region, wherever the two lines are meeting, that will be the corner points. So you can notice one is here 0 comma 3, other one is 6 comma 0. Only these two are, we have a corner points. So let's name this corner points as one, I'll take it as a, the other one I'll take it as a b. Okay, so feasible region exists for the given inequality. Or double shaded or blue shaded, here I'm using the color, so I'll mention that way. Otherwise double shaded or triple shaded portion. Okay, the blue shaded, I'll write it here, the blue shaded shaded is the feasible region for the given inequalities. So solution exists. So solution exists for the given z. Okay, for the given z. Now corner points are, and it is unbounded. It is unbounded. So do mention the feasible region and unbounded terms. Okay, unbounded. Corner points are, corner points are, first corner point, it's a 0 comma 3, and the other one 6 comma 0. Now let's substitute in the given z. Corner points, and what is the given z? Given z is x plus 2y. X plus 2y. So 0 comma 3 and 6 comma 0. So now let's replace here and get the z value. Z equal to, if x is 0 plus 2 times of 3, so what is the value? 6. Okay, now same way 6 comma 0, if you replace now here, z equal to 6 plus 2 times of 0 equal to 6. So same 6. So what we can conclude from this, both are minimum. Since they're asking for the minimized, no, it's a minimum only, we have to consider. Okay, so here 6 is the minimum, but we are getting in the 2 points, right? So 6 is the minimum value. Oh sorry, it's unbounded, no, sorry. 6 is may or may not be the minimum value of z. So what we have to do is, with the given inequality, okay, we have to frame a new inequality. So what is the given z? X plus 2y, right? X plus 2y. Since it's a minimum, less than symbol, what is the minimum value? 6. Now we have to draw the graph of this. So for that, solution we need to identify in the graph. That is, let x plus 2y equal to 6. Let's consider as a equation. Now we need to draw the line of it. So what we can do, we need 2 points. I think this x plus 2y already we have drawn here. Already actually we have drawn x plus 2y equal to 6 line already we have. So since already we have, then only solution space, let's identify x plus 2y less than 6. Less than 6, which side we have? Less than 6. So the given inequality, x plus 2y greater than or equal to 6 only we have drawn. Okay, so x plus 2y less than 6, obviously we will have a solution this side. Okay, excluding the yellow line, it's only less than 6, right? Less than or equal to 6 we didn't say. So that means below this yellow line only the solution space for the x plus 2y less than 6. Now the feasible region, and for this x plus 2y less than 6, do you see the any common point between them? No. Then we can confirm that 6 is the minimum. Okay, feasible region, feasible region and solution solution space of x plus 2y less than 6 does not have a common point. So 6 is the minimum, 100% we can confirm, minimum value of z. Okay, now at what points? At 2 points, no? One is at a point as well as b point. Since a and b, it looks like a straight line, no? So you can notice not only 0 comma 3 and 6 comma 0, any point you take, that is 4 comma 1 or whatever point which lies in this complete line segment. Okay, line segment from AB is the solution. Okay, so that means we will have a multiple results. 6 is the minimum value of the z uh, in all the points of AB line segment. Okay, so that's all the solution for this. Thank you for watching and please do subscribe. Thank you.